In the last a series of our sessions about ArchiMate enterprise development tool, I will be talking about the ArchiMate technology layer and cross-layer relationship and internal relationships within the layers. Technology layer is basically a layer that we construct our infrastructure and network and systems that all the other layers will be put on top of it. This layer consists of 9 separate entities, and I will go through all these entities and their relationships through this session. Many of the layers, many of the concepts have been inspired by UML2 standard, as this is the domain language and the de facto standard for describing software applications and infrastructure. However, when applicable, we draw inspiration from the analogy with the business and application layer as well. The first node that first entity from the technology layer that I will be talking about is a node. Nodes are active processing elements that execute and process artifacts, which are the representation of components and data objects. And nodes are, for example, used to model application servers, database servers, or client workstations. A node is often a combination of a software system and a hardware device, thus providing a complete execution environment for these entities. These subnodes that represent the hardware device and the software system may be modeled explicitly or left implicit within the node. Another entity is an entity called device. A device is a specialization of a node that represents a physical resource with processing capability. It is typically used to model hardware systems such as mainframes, PCs, or routers, basically hardware within the system. Usually they are part of a node together with a system software. Devices are can be or may be composite as well, and they can consist of sub-devices together. And another entity in this layer is the system software, and sometimes it is also called firmware. System software or firmware is a specialization of a node that is used to model the software environment. The software environment in which artifacts run. This can be, for example, an operating system, a Java Enterprise Edition application server, a .NET server, a database system, or a workflow engine. Also, system software can be used to represent communication middleware or things like that, like MQ series or similar things. Usually, system software is combined with a device representing the hardware environment to form a general node. Next entity that I'll be looking at is infrastructure interface. An infrastructure interface specifies how the infrastructure services of a node can be accessed by other nodes, or in other words, provider interface, or which functionality a node requires from its environment, in other words, a required interface. An infrastructure interface exposes an infrastructure service to the environment, and the same service may be exposed through different interfaces. Different interfaces, when we say, probably interfaces for different devices or different clients. Next entity is the network. A network represents a physical communication infrastructure. This may comprise of one or more fixed or wireless device or wireless network. The most basic network is a single link between two devices that sometimes we call peer-to-peer communication or peer-to-peer network, all the way to the most sophisticated network of thousands of different devices. A network has properties such as bandwidth and latency. It embodies the physical realization of the logical communication path between the nodes. Another thing after network we need to know is the communication path. A communication path is used to model the logical communication relationship between two nodes, two or more nodes. It is realized by one or more networks which represents the physical communication link. The communication properties such as bandwidth or latency of communication path are usually aggregated from these underlying networks. Next one is infrastructure function. An infrastructure function describes the internal behavior of a node. For the user of a node that performs an infrastructure function, this function is visible. If its behavior is exposed externally, this is done through one or more infrastructure services. An infrastructure function abstracts away from its implementation. Only the necessary behavior is specified. Next entity that I'll talk about is the infrastructure service. An infrastructure service exposes the functionality of a node to its environment. This functionality is accessed through one or more infrastructure interfaces. It may require use and produce artifacts. An infrastructure service should be meaningful from the point of view of the environment. It should provide a unit of functionality that is in itself useful to its users, such as application components and nodes. Artifacts. An artifact represents a concrete element in the physical world. It is typically used to model things like software products, such as source files or executable files, scripts, database tables, messages, documents, specifications, and model files. An instance or a copy of an artifact can be deployed on a node. A artifact, it can be used to represent a physical data component that realizes a data object as well. Okay, so this way we already went through all the entities of all three different layers so far. Technology layer in this session and business and application layer in previous sessions. Now I will be talking about the ArchiMate cross-layer dependency and relationship. What that means is that when we are developing enterprise architecture in three different layers, a business layer on the top, application layer in the middle, and the infrastructure or technical layer at the bottom, technology layer at the bottom, most of the time it is necessary that make connection and relationship between elements or entities across layers. For example, some entity from business layer down to the layers below it. And now we want to know how we can make and what type of relationships are available for us to make such communications possible. A central issue in enterprise architecture is basically a business IT alignment. How can these layers to match is the question. In this session, I'll describe the relationship that the ArchiMate language offers to model the link between business, application, and technology layers. I mean, across the layers, not internal to the layers. Although we need some relationship entities to depict and represent internal relationships as well. Business layer and lower layer alignment is an important thing. To do that, we use a relationship called used by relationship between application service and the different types of business behavior elements, and between application interface and the business role. These relationships represent the behavioral and structural aspects of the of the support of the business by application. And another relationship type that we can use is the a realization relationship. A realization relationship from a data object to a business object to indicate that the data object is a digital representation of the corresponding business object. The other relationship again is the assignment relationship, where we use assignment relationship between application component and application processes. Function or interaction and between application interfaces and business services to indicate that, for example, business processes or business services are completely automated. The case that the business process, function, or interaction is not completely automated, but only supported by an application component is expressed with the used by relationship. Another cross-layer dependency type is the application and technology alignment, where we wanted to make relationship between elements from application and technology layers to each other. And again, we use used by relationship between infrastructure, service, and the different types of application behavior elements, and between infrastructure interface and application components. These relationships represent the behavioral and structural aspects of the use of technical infrastructure by applications. And of course, the other type of this relationship is a realization relationship. where a realization relationship from artifact to data object to indicate that the data object is realized by, for example, a physical data file. And from artifact to application component to indicate that the physical data file is an executable that realizes an application or part of an application. But we also need to note that in this case, an artifact represents a physical component that is deployed in a node, on a node. This is modeled with an assignment relationship. A logical application component is realized by an artifact and indicatedly by the node in which the artifact is deployed. This concludes the inter-layer relationship components. I'll just briefly go through other relationship types that is available in ArchiMate. There are of three types of relationships. One is the structural relationship that allows for notations such as association, access, used by that we already talked about, realization also we talked about, assignment we already talked about, aggregation. Most of these relationships are borrowed from UML2 format and are used exactly as it is used in UML. Other two or three types of relationships are also dynamic relationships and other relationships such as grouping, junction, and specialization relationships. Specialization relationships is also depicted as known as inheritance relationship. Okay, here we already concluded all the syntax and specification of a tool called ArchiMate that allows us to build or develop all the artifacts and all the design artifacts for any stage mentioned in ADM or as part of TOGAF enterprise architecture framework.